Each of these projects had a different fate. The projects differed in their cost of creation. The Tevatron, despite solving the new and ambitious task of creating a technology for the production of superconducting magnets, cost around $500 million. The expected cost of the UNK proton accelerator was estimated about 4 to 5 times higher. The project of the superconducting supercollider, according to the estimation of the US government, was supposed to cost around $12 billion. Not all those projects were completed. What was the reason for that? The most dramatic was the fate of the superconducting supercollider in the US. By 1993, a 23.5-kilometer-long tunnel had already been bored. The assembly of equipment for the injection chain of the main accelerator had begun, and around $2 billion had already been spent on the implementation of this project. Then, on the 21st of October 1993, the US Congress cancelled the development of this project. In fact, this decision wasn't made out of the blue. It was momentous for the entire field of high-energy physics at the end of the 20th century. What caused such a decision? Perhaps it was not clearly communicated. On the one hand, 1993 was the year when the Soviet Union had already ceased to exist. One of the reasons to cancel the project of the superconducting supercollider was that the US no longer had the necessity to further prove its scientific and technological supremacy. The enemy that it had been fighting had disappeared. On the other hand, a previous generation of accelerators, which did or did not apply superconductivity, had practically completed the creation of the theory of strong interactions and the theory of elementary particles. The so-called Standard Model was created, which comprised the theory of electroweak interactions and quantum chromodynamics, that is, the theory of strong interactions. This theory effectively crushed those naive expectations which had emerged from the moment of the discovery and invention of quarks as well as of partons in protons. The process of proton decay had practically vanished due to it having a low success rate. Mankind realized that access to new energy sources was impossible. There is an analogy with the beginning of the 20th century, where the development of nuclear physics, which had been following the same path as the succeeding development of particle physics, had led to the creation of an atomic bomb and nuclear plants. This development was nothing more than déjà vu, and it had nothing new to offer mankind. The US Congress acknowledged exactly this fact. High-energy physics ceased to be the principal science of humanity. Human development was to follow another path. High-energy physics is only of interest to fundamental science. This was the decision made by the Congress of the US. Perhaps it didn't sound so clear. Following the closure of the superconducting supercollider project, the accelerator accumulator complex in the USSR was cancelled as well. Nuclear weapons tests ceased in the Soviet Union in 1991, and in 1993 in the US. In 1996, these countries were followed by the UK, France, and China. That unusual process, which had been unfolding since maybe the first decade of the 20th century, had practically come to an end. What kind of process was that? Here I have outlined some of its features. Maybe I should touch on it in greater detail. This was an exponential growth of almost all the parameters which could be used to characterize the population of our planet, mainly the involvement of power sources for production. During that process, phenomena started to emerge on the surface of the Earth that had never been in the biosphere before. An immense quantity of matter was being moved by millions of tons. This matter was turned into machines and somehow scattered around the globe, and then turned into scrap during the wars. Nuclear power plants were lit on the planet. For 50 years, the planet was shaken by nuclear explosions. The drops of matter from the surface of the planet went outside the atmosphere, reached the solar system planets, and went beyond the solar system. Radio frequency radiation from the surface of the planet reached the levels typically found in the stars. That means the Earth blazed up like a new star in the radio frequency range. Since the 90s, all these processes have been on the wane. It is a combination of these parameters, the sharp change and fluctuation in parameters, which are characteristic of a phase transition. What phase transition happened on the planet Earth? Perhaps naming it doesn't mean explaining it. The name of this transition was formulated by Vernadsky as early as in the 30s. According to him, we live in an era where the biosphere is transformed into a state called noosphere. Starting from the information of the noosphere, a crucial role in the development of planet Earth is played by mankind and science. This transition process turned out to be wonderful and may be incomprehensible for us. We are trying to explain it from the viewpoint of some political military confrontations or something similar. If a physicist glanced at this process from an outside perspective, they would say this is a characteristic picture of a phase transition. The transition was almost finished by the end of the 20th century. Planet Earth has entered a new development state where the population of the planet is practically stabilizing. The emergence of new power sources is practically unexpected. Further development follows the path of the self-perfection of already mastered energy sources. If we speak more superficially, in a more conventional way, among most of the people, the interest in high-energy physics and physics itself has disappeared. Physics has stopped being the principal science. These new realities had been understood in some way and used to form the basis of the main program of the strategic development of science and technology in the Russian Federation. What realities are those? Indeed, this heroic attack undertaken by mankind against the law of nature to find new ways of development led to the creation of many unique facilities. These unique facilities have fallen short of the tasks and hopes they had been entrusted with. But they have resulted in the invention of new technologies and have become the instruments in the development of new technologies in completely different areas of science and technologies. Perhaps illustrative is the fate of the old accelerator facilities, which had been built for experiments in high-energy physics. A part of them had not been finished and had been abandoned. Those include the 20-kilometer-long tunnel of the accelerator accumulator complex in Pratvino, the 28-kilometer-long yet unfinished tunnel in the US, and other tunnels in Germany and the US, along with the equipment that is no longer in service and most probably will never operate again. Other facilities have been adapted and rebuilt for other purposes. For example, the linear accelerator at Stanford University, which had laid the foundation of the exuberant research in particle physics, was converted in 2008 to a driver for an X-ray-free electron laser.